Here we go. Let's take a look at this. On the non-graphing calculator test, I've identified this is the one. If it weren't for this problem, okay, listen, I don't have any time for this. Okay. On the non-graphing calculator test, this was the one problem that cost people fits. If it weren't for this, people would have done great on this test. This is the one that people are having trouble with. So let's hit this one more time. It's not a big deal, really. What you're supposed to do is write the equation of that radical function. They're all going to be either square roots or cube roots, right? So is this a square root or a cube root? It's a square root. How come? Okay, because it has a starting point. It only goes in one direction. A cube root would look like a hurricane when you see a satellite picture, right? It kind of does that. Okay, so this is a square root. Now all we have to do to come up with the equation of this thing is fill in the blanks, right? We know that it's always going to be like this. Y equals some number a that we have to find times the square root of x minus h plus k. If I just knew the values of those things, I plug them in and I'm done. It's that simple. I can find all those things from the graph. Okay, now where's the special point where I get h and k? Not the middle one. It's the starting point for a square root function. It's the special point. Okay, so this is the one that we're using for h and k. Right, it's the initial point for a square root graph. Well, what are the coordinates?
5, -5.
5, -3. So h is 5, k is -3, right? The only other thing we have to do is we have to find a, right? But a is simple. We go over by 1, and then this is the value of a. So it's positive or negative?
Positive.
Positive 2. So a equals 2. Plug that stuff in, and we're done. That's it. So what's our answer? Our answer is a is 2 times the square root of x minus 5 plus -3 is -3. That's it. Right? Nothing more to it. Okay, how about a cube root? Where's the special point for a cube root? The middle point. Okay, so what are the coordinates of the special point this time? 2, -4. So we get h is 2, k is -4. Then all we have to do is find a. Now, how do we find a for a cube root? Same way. Yeah, we go 1 to the right. Whoops. We go 1 to the right, and then the question is, how much is it changing? -2, right? So a is -2. And then all I have to do is plug into my graph y equals a times the cube root of x minus h plus k. Only difference being it's a cube root instead of a square root. If we plug stuff in there, we just get -2 times the cube root of x minus 2 minus 4. Now the part that you could mess up on this, that -4, inside or outside the radical?
Outside.
It's got to be outside.
Outside. Outside.
You have the benefit of this fancy, what you see is what you get editor too, so that's very helpful. You really can't get that wrong because it's, when you hit accept or whatever, it's going to render that thing and it's going to give you one final chance to see what you got before you hit submit, right? Okay, what about, this is the only other one that seemed to cause much in the way of problems was this guy. And it's not hard, is it? What do we do with a problem like this? If I want to solve this for x, square root 3 minus x was x minus 1. What do? Square it. Good. I'm going to isolate the radical, already done. The radical is already by itself on one side, and then I use whatever power I need to cancel the radical. Well, this is a square root, so I'll just square both sides, right? If I square the left side, the square and the square root cancel, correct? So I get 3 minus x, and then over here, I get x minus 1 squared, which is really just x minus 1 times x minus 1. And so if I FOIL that out, what is that, x squared minus x minus x minus 2x plus 1, or use the expansion pattern if you'd rather. So all I have to do now is go back to chapter 5 and just solve a pretty simple quadratic equation. What do I do to solve a quadratic equation? Okay, I add x and subtract 3. I got to get it all equal to 0. Put it in standard form. So minus 3 plus x. Okay, so those guys go away. I'm left with x squared minus x minus 2 equals 0. But let's go ahead and put the equals 0 over there. How about it? Okay. Now, what are my options? Quadratic formula, or probably easier. Well, except this is the non-graphing part, so you couldn't do that. So what's your other option? For factoring. Sure, we could just factor this thing too. We could use a is 1, b is negative 1, c is negative 2. But we could also just factor this thing. What's it factor into? X minus 2, good. X plus 1. So if I set those equal to 0, x minus 2 is 0 when x is 2, good. X plus 1 is 0 when x is negative 1, right? And then, am I done? No, there's one more step. Because I squared both sides, what do I have to do? Got to check them for extraneous solutions. I got to check those by plugging them into my formula. So if I plug those in, let's see what we get. If I plug in x equals 2, I get the square root of 3 minus 2 equals 2 minus 1. Well, square root of 3 minus 2 is square root of 1, which is what? 1. So I get 1 equals 2 minus 1 is 1. Yeah, it is. Check. So that one works. Okay, let's try the other one. If I try x equals negative 1, I get the square root of 3 minus negative 1 equals negative 1 minus 1. Well, what do I get on the left side? 2. On the right side? Not equal. So x equals negative 1, we have to get rid of. That one's not a solution. So then it wants us to enter all our solutions in numerical order. Well, how many solutions do I have?
2.
I have 1. So the only solution I get is 2. So therefore I just put NA in the other 2's to cancel them. Don't need it. Right? Okay, questions? Good, okay. All right, on the graphing calculator part of the test. Okay, this one is, I would claim, an absolute freebie. I mean, seriously, you've got to get 100% on this. There's no reason not to. There's no reason not to. Now let's look at this real quick. Okay, first of all, if I want to, if I want to solve this equation graphically, I mean, we know how to do this non-graphically, sure, but if I want to solve this graphically, what's my trick? Yeah, y1 and y2. Graph the left side is y1, the right side is y2, and just ask the question, when does y1 equal y2 on the calculator? When do they cross? So y1 is just going to be 2 times the quantity 3x plus 4 to the power of 1/3. Right? Okay, there's y1. Other side is just x minus 6. Right? Okay. If I just go zoom fit, or zoom standard, how about, just kind of get the ball rolling here. There's my cube root function, and there's my line. Now, we can make this thing a lot bigger if we want to, but you already know what's going on. The shape of a cube root function is, now watch this closely, as I go down to the left, what's going to happen to the shape of this curve? It's going to, well, it never goes up, but it really flattens out, doesn't it? This curve is just going to kind of gradually, this one, if I continue it along, it just kind of stays, it doesn't go down much from there, does it? But the line, on the other hand, is going to go down and get further and further away from that cube root, isn't it? Right? Is there going to be an intersection to the left? No way. What about to the right? Well, if I continue this curve along, it does that. If I continue the line along, it's already crossed in there somewhere, hasn't it? So how many intersections are there going to be? 1. Sure. And if we're not comfortable with what I just showed you, I mean, make the window bigger. Just make it go from negative 50 to positive 50 on both axes if you want to. That's fine. You can always make it bigger. And hit graph. And now you can see pretty clearly there's the cube root. There's the line. Obviously, they're only crossing in one spot, right? Want to find the intersection? Well, second calc intersect. Remember what I do? I hit enter twice. And then when it wants a guess, I just kind of go up close to the actual intersection. Close enough. And as long as it goes to it, there, it found it. It's 13.00819. I don't know how many decimal points it asked for it, but just follow the directions. Yes, sir. Okay, you put it in wrong. We'll look at it. We'll look at it the same way you did. Oh, you have the old operator. You need to put those in parentheses. Just taking it to the one column, right? If you don't have that fancy operating system, put that on.
I know there was one question that had flat drop of the line, it was negative X.
Hey, quit talking, please.
It was negative X, and it had a cube root graph, like that. It did look like it kind of petered out, but given the nature of the cube root, say you go out to negative, say, 125, and the flat
It flattens out.
lies at 5, wouldn't that be a negative 5 then?
Well, why don't you show me when we get down there? Show me the one. I'll look at it on your test and see. Okay, now here's what happened to Luke. So be careful about this. If your calculator doesn't have the newer operating system, so it automatically knows to put that 1/3 in the exponent, then you have to do it like this. Okay, I'm kind of glad that came up. We would have had to have entered it like this: 2 times 3x plus 4 to the 1/3 in parentheses. Because if you don't do that, it's going to take this whole thing to the 1, evaluate that, and then divide the whole answer by 3. See what I'm saying? Only if it's automatically putting it up in the exponent can you not put parentheses around the exponent. Otherwise, you need them. Make sense?
Yes.
Okay. All right, so that one's done. How about moving on here? Yeah. So the answer is, whoops. Yeah, whatever it was, 13 whatever that intersection was, 13.008, something like that.
And it wants the X value?
Yes. Yeah, once the X value, because, look, the question is,
Oh, okay.
it's an equation involving X's only, right? Okay, questions? Okay, what about this guy? Okay, there are a couple ways to do this. Now, you can, if we want to, this is okay to do. We could just do the same trick. We could graph X to the, let's clear that whole thing. We could just graph X to the 8th and 6,071. That's a big number, sure, but we may have to just go out a ways, but we really won't, because an X to the 8th goes up in a hurry. So if I just go zoom 6, obviously 6,071 is way up there on the roof somewhere, right? So I can see there's my X to the 8th function. What if I go zoom 0? Yeah. Then I get this huge function that's X to the 8th, and then you can't even probably see the 6,071. It's too close down there. So we made the window too big. The window went up, oh, that's a little big for the Y max, isn't it? What if we just made it go from Y min 0, Y max is 7,000? Because we were trying to find when the function has the Y value of like 6,000 something, right? So we'll make it 7,000. So there's my power function, X to the 8th, and there's the other one. Find the intersections. There's 2 of them, right? Okay, that's fine. I got it, and I want to find the least, so I picked the left one. Agreed? Now, there's a much easier way to do that though, isn't there? We don't have to do all that stuff. You can graph it. Maybe you wanna just check your solution by graphing the function too. But how do we do this? We don't even really need to find an intersection on this one. What do we do? Eighth root it, sure. But what do we need if that's an even? Plus or minus, right? So all I'd have to do then is just go 6, 0, 7, 4 to the 1/8.
It's 0, 1, or
Whoops.
6, 0, 7, 1.
Whoops. 1 to the 1/8, and it's gonna be plus or minus that, right? Okay, the other thing I could do, and this is probably way overkill, is I could even use poly small.
Wait, that's not, that's the answer.
That's the answer, yeah. It's plus or minus, I mean, that's it. If I use poly small, I mean, like I say, I think this is like super overkill, but if I did this, poly root finder, what's the degree of the polynomial, the order? 8. Now, what I'm gonna have to do here is I'm gonna have to set this whole thing equal to 0. X to the 8th minus 7, 6071 equals 0. So I'm just gonna find the zeros of that. So it's an 8th degree. I mean, wouldn't you agree this is way more than you need to do?
Yeah.
This is like bringing an atomic bomb to a gunfight. It's a little more than you want probably, but. And we're supposed to round this to how many, we don't know how many places. Let's just pretend it's 2. I don't know what it said. What did it say? 4? Okay, so we'll go down. Make this 4. Next. A sub 8 is 1. A sub 0 is
-67.
okay.
Just too much.
Solve. Oh, I gotta put zeros in for all. Well, anyway, see, this is too much. You don't want to do all this stuff, do you? I mean, this is. I could put zeros in for all those, and it would tell me, but that's way too much stuff. It is. I agree. Okay. So what about this guy? Same thing, right? And this is one where, once again, I mean, I could just square root both sides and do it that way, or I could just graph both sides and find the way they cross. There's only 4 problems on the test. Take your time. Do it both ways. Check your answer. Might as well get 100% on this one. Okay, make sense?
Yes,
Yeah.
we're good?
Okay, so I'm guessing. Hey, am I right in concluding that you would rather not rather just cover the new material all tomorrow, all in one shot, go to the lab today? You want- Okay, so let's go. 205.
Hey, Mr. Moya?
Yeah.
Do you have transferring tables and a calculator to calculator?
Yeah, I can transfer stuff.
Yeah.
Well, I know how to